Hi, I'm Chiu-Hsuan from National Jiao University, Taiwan. I'm glad to be here to present our work, Slice of Life, Transparent and Integrative Transition Among Realities in a Multi-HMD-User Environment. This work is done with my colleagues Chia-En from NCTU, Seraphina Yong from NTU, and my advisor Liwei from NCTU. Here is a short video to introduce Slice of Light. Slice of Light is a visualization design that enables an HMD user to oversee and transition between multiple collocated HMD users via words. With a strike gesture, the HMD user can transition into a via word. After entering, the user still can see other HMD users' reality and establish a communication channel with the current via words user. With the same gesture, she can also step back to the physical reality. Let's talk about our motivation. The high levels of immersion and visual seclusion provided by HMDs isolates users in virtual environments, which results in a communication gap with the outside world and non-HMD users. To solve the communication gap, several works have been presented. Some research explore bridging the gap between HMD and non-HMD users. Works such as Share VR and Dollhouse VR presented interfaces to allow non-HMD users to participate in the HMD user's activity, while shared space enables non-HMD users to communicate their needs about physical space allocation. Another category of papers tries to externalize the virtual environment, hence allowing non-HMD users to understand the VR user status. For instance, face display and front face utilize an add-on front display to visualize the VR user's experience and gaze. On the other hand, Let Your World Open and VLEGO 2 externalize the 3D virtual environment using projection or AR glass. While these works have externalized the virtual world to lower the communication gap between the VR and external users, the proposed methods are limited to only one HMD user. In this work, we extend the design concept to a more complex scenario, that is, one with multiple collocated HMD users. Hence, we present Slice of Light. Slice of Light is a visual design that aims to enhance transparency and integrative transitioning among realities of multiple HMD users. To identify HMD user context, we now define terms related to each user's role and presence in a reality. An HMD user can be either a reality local or reality guest. Reality locals are fully immersed in one reality. They can only hold presence in one reality at a time, either the physical or virtual reality. Here we have three reality locals. Two of them are in virtual reality, and the other is in physical reality. The two virtual reality locals are situated in reality green and reality yellow. Therefore, there are in total three realities in this environment. While reality locals switch their role into reality guest mode, a green crystal appears above their head. Reality guests can view across and transition among other HMD users' realities. So now we can present the view design for reality guest. Each HMD user's reality is represented by a slice of light that appears in the reality guest view. Each slice of light resembles a sliced cut of each HMD user's reality. This slice of light is casting into the reality guest's local reality. So here, we have two slices of light from the two reality locals, casting into the physical reality. To facilitate transitioning among realities, the slice of light is also an entryway into the remote reality it is showing, and the reality guest can transition into it by stepping on the corresponding slice of light. We can explain in detail with the education-based scenario. Here we can see the instructor and two students, 1 and 2, immersed creating block design in reality green and reality yellow. The instructor can see the student work progress with slice of light interface. She steps into student 1's slice of light and transitions into reality green to communicate with student 1. With slice of light, she can still see the other student progress. After the discussion, she steps back to the physical reality. Now, about the interaction design. As we mentioned, an HMD user is either a reality local or reality guest. To identify an HMD user's role, a green crystal is added above the reality guest head. Therefore, when entering to a local, the crystal will disappear. Slices of light in the view dismiss as well. The reality local is then fully immersed in the current reality of their presence. For a reality guest, each slice of light resembles a slice portion of each HMD user's reality. A thin cut of the virtual environment is displayed on the inner surface of the slice, and the volume of the wedge contains 3D elements that fall inside the range of the slice of light. This allows the wedge to present the reality background environment with the HMD user's foreground interaction. We present the portal. The portal is a grounded widget that always follows the reality guest. Slices of light reach the guest feed within the set stepping range. This resembles a generic off-screen indicator and encodes the HMD user's direction and proximity to the guest. The portal implements the transition function. To enter an HMD user's remote reality, a guest can step on the corresponding slice on the portal. So here, by stepping a slice of light from reality yellow within a stride gesture, the reality guest present switches to reality yellow. Here's an example in the scenario. There are two reality local and one reality guest in the environment. If the guest places one foot on the slice of light, the slice widens to give visual feedback. When the stride gesture is completed with the second foot, a transition to the corresponding reality is activated. The slice starts to expand until the guest is fully immersed. The guest present then switches to the current local's reality, with one slice appearing from the other reality local and a new slice, which we call reality slice, coming from the physical reality. If the guest wants to transit back to the physical reality, they can step on the reality slice and switch the presence back to physical reality. HMD users, no matter their role are local or guest, have open communication channels when sharing the same reality, which means they can talk and are visible to each other. However, only locals can influence the reality. That is, only reality locals can modify the reality content. So far, we have presented the design and basic interaction offered by the slice of light interface. Let's continue with the multi-reality scenario. After the instructor steps back to the physical reality, she then goes to the slice of light from student 2. Then she transitions herself to reality yellow. In the meantime, student 1 has finished his work, so he transitioned himself to reality yellow as well. Student 1 then walks to stand in front of student 2 after informing the instructor. He switches to reality local to help student 2 with the design. And finally, the instructor steps back to the physical reality. So what was our implementation for slice of light? Here's the equipment for our HMD users, which contains a dual-functioning HMD and a stereo camera kit for depth sensing and spatial mapping. To track users' foot position, we attach trackers to their shoes. A physical switch is added to the HMD. This switch provides a tangible interface for quick swapping between the local and guest role. To compose a slice of light view, we need to blend all HMD users' separate realities into the guest local reality. We stream the renderable data such as tracking position, video stream, and interaction data from each HMD user to the guest reality in real time. For more detail about the slice of light formatting and implementation of the interactive component, please refer to our paper. Our design insights. To inform design of interface for managing collocated HMD users' reality, we recruited experts from NVIDIA Interaction Design and HCI to experience the scenario we provided and give feedback about the effectiveness and usability of slice of light. All participants completed the task and responded positively to slice of light. They expressed that the visual design was helpful for understanding other HMD users' virtual environments. Based on their feedback, we deliver our design insights. When presenting the HMD user's reality context, occlusion and visual clutter problems are inevitable if many HMD users appear in the guest view. Some solutions, such as scaling the visual design based on a determined priority, or interactive control such as gaze and gesture, can be considered to alleviate this problem. In this work, we propose stride gesture to interact with a slice of light. However, stride gesture might cause fatigue and increase required space for the interaction. More space-efficient gestures such as foot tapping or hands-free navigation gesture can be considered. Since the guests have a heightened ability to assess the locals' reality, it is important to notify locals of the guest's participation in their reality, or the locals might not notice it. To ensure locals' awareness, an on-screen notification can be added once the guests join their reality. Some points about limitations and future work. We presented some direction for improving user experience as well as future concepts for how slice of life design concept can be applied. Firstly, in this work, we would like to demonstrate the interface's main feature. Will allow HMD users to transition between realities without enforcing permissions. But due to VR locals' privacy concerns, a commitment process can be added to obtain locals' permission when the guests desire to enter their reality or switch roles. Second, since the slice of life reveals its user interaction context, it might cause privacy concerns for the user in a slice. Some strategies such as video manipulation or semantic abstraction can be considered in future versions to preserve some level of privacy. While this work assumes that all users are HMD users, our design does not conflict with previous works for non-HMD guests using methods such as an add-on display on the HMD. By applying slice of light on the add-on display or floor projection, non-HMD user can be included in the collaborative scenario as well. Finally, in this work, we assume all HMD users share the same physical environment in our scenario. However, slice of light is also flexible enough to apply to remote user setups as well. For instance, with the physical environment being fully captured, slice of light can be also applied to a telepresence scenario that connects different physical locations. Now, I will sum up the talk with our contribution. In this talk, we presented slice of light, a visualization interface that aims to communicate HMD users' experience among multiple realities. We presented the primary functions of slice of light and demonstrated its usability in application scenarios. We also conducted a user study to deliver design insights on managing multiple co-located HMD users' reality. So thank you for your time watching this presentation, and I would also like to thank all my colleagues and my advisor. If you have any questions or comments, feel free to contact us.